Hi, and welcome back to Null Zero Labs. And in today's episode, we are back at looking at OSPF. We are going to take a look now at some multi-areas. I was going to do a slideshow to go along with this, but I've been so busy recently that I just haven't had the time. But I thought what we would do is instead, I would just jump into the lab environment. We will just run through building the multi-areas, show how it works, and then give you an overview of the different concepts like summarizing from one area into another and receiving and redistributing external routes in between those areas. So let's jump into the lab and take a look. So here we are in the lab, and what we have is 3 areas and a external link to a separate autonomous system. So a separate autonomous system is something that is not part of our routing domain. So obviously in this case, it's an external gateway to an internet provider. We have area 1, area 0, area 2. All areas must connect to area 0, and that connection is achieved via an area border router. So this router here is an area border router because it connects to area 0 and to area 2. Same over here, area 1. Its router connects to an area border router, which connects to area 0, but it's also connected to this internet provider, which isn't participating in our OSPF routing. So it's an external provider. So that's to an external autonomous system. So it's an area system border router also, because we are linking to other networks that are not part of our routing environment. We have our router in area 1 and our router in area 2. Those are configured just for those. You could again have, say, area 3, but again, we want to link that to area 2. You can do things like virtual links where you can go from area 3 connected to area 2 and do a virtual link to area 0. But again, if you're looking at that point, I think you've already done something wrong. You should go back and look at how you've constructed your network to start with. So all these routers at the moment are configured with their basic IP address information. We have no reachability from this router in area 1 to these IP addresses in area 2. We have no reachability to the internet up here from any of these devices. So that's what we're going to jump into and do. So let's start with area 0 because it's got the most devices. And let's start with router 2. So I'm just going to move it over here to the side so we can see its interfaces whilst we work on them. So if we do a show IP int brief, we can see that we have our interface G0/0, which is going into area 1. And we have our G0/1 and our G0/3, which are our interfaces towards our other routers within area 0. And we have a link on G0/2 to our external. And obviously all of our devices have a loopback address because that's what we're also going to be using for our OSPF router ID. So let's start with the simplest one. Let's get our external gateway done. And we know that that's not participating in our OSPF process. So that's just going to be a default route. So we're going to do an IP route, our default, and we are going to route it to 192.0.2.1. And now we can do a test. We can ping 192.0.2.1. We can reach that gateway. Now let's ping 8.8.8.8. There we go. And we can see router 2 has reachability to its internet uplink via that interface. So that's all good. Obviously, any other router at the moment cannot reach it. So now that we've done our external, that's all we need to do. Let's configure our OSPF process and get our area 0 configured, this area here. So we're going to configure this first. So let me just, if I move this there, we can see all of the interfaces at the same time. There we go. So a router 2, we know that we will need config T. We need a router OSPF. We'll call this process 1. Our router ID is going to be 1.1.1.2, which is our loopback address, 1.1.1.2. Our passive interface is going to be default. So we want all of our interfaces to be passive unless we specify that we want to run OSPF on there. So we're going to see that we're going to need to be running OSPF here, here, and here. We don't want to run it here because that's an external provider. So we're going to say no passive on G0/0, G0/1, and G0/3. Do show run. Let's have a look at our OSPF process. So there we go. We can see we've created our OSPF process. We've given our router ID, and we've said that we're expecting to participate in OSPF on these 3 interfaces. Okay. So now let's put those interfaces into the correct areas. So we're going to start with area 0. So we want G0, G0/3, and we want the loopback. So in L0, IP OSPF 1 area is 0. That lives in our area 0. Int G0/1 IP OSPF process 1 area 0, and int G0/3 IP OSPF 1 area 0. Now the next thing to remember is because these are just a single connection between router to router, we don't want any DR and BDR election processes happening like we discussed in a previous video. So what we're going to do is we're going to make these interfaces point to point so that if there is a failover, say this link drops and traffic has to take this path to get around in area 0, the process will be quicker, the failover will be quicker. So in G0/1, IP OSPF network is going to be point to point. In G0/3, that is also a point to point. And in G0/0 is also a point to point interface. So let's take a look at what we've configured. We have our loopback interface configured and participating in OSPF. It's advertising itself into OSPF area 0. We have our link into area 1 configured. No, we don't. We haven't configured that one yet. We've configured it as point to point. We need to put it into its area, which we will do now. We've configured our external link, G0/1 and G0/3. So this leg, again, because this is a area border router as well as an area system border router, int G0/0, we're going to advertise that one as IP OSPF 1 area 1. So the same process number, and again, the process number doesn't have to be unique. It could be a lot longer number, it depends on what you want to call it. And we're putting this interface in area 1. So this router has an interface in area 1 and 2 interfaces in area 0. So we will save that. Let's configure router 6. This one will be a lot easier because it only has the 3 interfaces to worry about. So we are going to config T in L0. Oh, actually, we better set up the process first. So IP OSPF 1. Oops. IP router even OSPF 1. Our router ID is going to be 1.1.1.6. Passive interface will be a default, and we're going to do a no passive interface on G0/3 and G0/2. Now we're going to advertise our interfaces. So int L0, IP OSPF 1, area 0. It's our backbone area. Int G0/3. We're going to advertise that in our backbone. And int G0/2. We're going to advertise that into our backbone. Take a quick look. So loopback, process 1, area 0, interface towards router 3 in area 0, interface towards router 1 in area 0, and our configuration for the OSPF process. Just, you can see router 2 has now had an adjacency come up towards router 6, so 1.1 and 1.6. So it's received a potential network mistype. So what do we do wrong? Let's do a show run. And we can see that what we failed to do was we didn't configure the network type for the interfaces. So let's do that now. G0/3. Our IP OSPF network type is going to be point-to-point. And in G0/2, again, it's a point-to-point interface. It's single router to router, no multi-mode required. So now let's do a show IP OSPF neighbors. We can see that we've got a full neighbor relationship now with router 2. So that's correct. So now let's jump onto router 3 here and get this one configured, and that should complete our area 0 configuration. There we go, router 3. So again, router 3 has got 2 interfaces into area 0 and an interface into area 2. And because it has no external connection to a external gateway or any other autonomous system, it is just known as an area border router. So router OSPF 1. Now router ID is 1.1.1.3. Passive interface will be default, and no passive interface on G0/1, G0/2, and also on G0/0. There we go. Now int L0, IP OSPF 1, area 0. Int G0/1, IP OSPF 1, area 0. IP OSPF network type is point-to-point. And int G0/2, IP OSPF 1, area 0, and our network type is point-to-point. Now finally, our G0/0 is going into area 2, so we're going to place that one in area 2, and it is also going to be a point-to-point towards router 4. So int G0/0, IP OSPF 1, area 2. And our IP OSPF network type is point-to-point. Save that, show IP OSPF neighbors, so we can see our neighbor relationships. We can see router 3 has a neighbor relationship with router 6 and 2, which is correct. So let's check router 6. And there we go. And finally back on router 2. We can see the other two, 6 and 3. So let's do a show IP route OSPF. Let's see what we've learned. So we've learned these. So router 2 has learned about the loopback 1113 from a router 3. It's learnt about the loopback address 1116 from router 6. It has learnt about 10.10.04/30, which is this link between router 6 and router 3. And it's learnt about it via 10.10.09, which is this leg. So it's learnt about this leg from here. And it's also learnt about it from this leg here. So it knows that if it wants to reach this, it can get to it this way or this way, depending on which one is up. And then we have this inter-area route showing of 10.10.20, which shows that it has learnt about this leg. And as we know, we are advertising this in area 2. So it is being tagged as an inter-area route. So if we look up here at the codes, we can have a look. If I can find it, we should see a big capital IA. There we go. So it is an inter-area, an OSPF inter-area. If it is a smaller one, like an IA in lowercase letters, that's a ISIS inter-area route. So we've seen this route of IA. Let's jump down here to route 6, router 6, this one down here. Let's do the same, show IP OSPF route, or show route IP route OSPF. So now we see this one down here has learned about 2 inter-area routes, because obviously this one is the border router. It knows about this leg, so it doesn't have that. This one down here is not connected to any other area than area 0. So you can see that it's learned about this leg, which is in area 1. So it's an inter-area route. It's learnt about this one, which again is in area 2. So it's learnt about that inter-area. So router 6 can see 2 inter-area routes. What it can't see at the moment is the default route. Same for this one here. None of these other routers can reach the internet gateway because we're not advertising it. So that's something else we're going to do now. So back on router 2, we're going to go into our IP OSPF process. So IP router OSPF 1. So we want to originate our default route that we added. So if we find here, we should see this default information. So we're going to go default information, and we want to originate it. And I'm going to say always for this one. So because this is the only gateway, so we are going to always originate a default route from here. So I'm going to hit that. I'm going to show a run. So we can see under our OSPF process, we are saying that we are going to originate the default route. And we can see that we have a default route. No other router in area 0 has a default route, but we do, and we're going to advertise that default route into OSPF so our other routers learn about it. So now if we go down to router 6 and we do a show IP route, we can now see that we have another one showing up. We have this E2, and it's learnt by OSPF, and it's the default route. So if we look at the table up here, we can see that it is an OSPF external route. So we have learnt about the external route from router 2. So we have learned about the external route from this ASBR router, router 2. So that's how we've managed to originate our default. So now if we ping 8.8.8.8 from router 6, you can see that we are now using the default route to reach that, because we have no route to 8.8.8. We only have a default route. So now we know that if there's any network that is not advertised, it's going to go to router 2 and make its way to router 5. So if we jump over to router 3 and we do the same, show IP route OSPF, we can see again we have learnt about the inter route from area 1, and we've learnt about the external route from our internet gateway that is being advertised by this ASBR. Perfect. So we've got our basic backbone area configured. So area 0, we class it as area 0. We also call it the backbone area, as all other areas must connect to the backbone. Now that we have our area 0 configured, let's configure our routers inside each of our areas, area 1 and area 2. And then let's take a look at how we're going to advertise some routes out of these zones. So if we jump onto router 1, the configuration is going to be fairly similar. So config T, our router OSPF, let's just give this process ID of 10 so we know it's different. Our router ID is going to be 1.1.1.1. Our passive interface will be default. No passive interface on just G0/0. It's the only interface we're expecting any kind of OSPF neighbor relationship to be formed. In L0, IP OSPF 10 for the process. The area is 1. There we go. And the same for our int G0/0. IP OSPF 10. Area is 1. Our IP OSPF network type is point-to-point. We can see we've had a neighbor relationship come up. Show IP OSPF neighbor. You can see that we have a neighbor relationship with the ASBR router 1.1.1.2. Show IP route. We can see that we have learnt about the default route from this gateway, and it is coming into our area. And we have learnt about all of the other areas. So all in here, every other thing that is not area 1, so area 0, area 2, they are all classed as inter-area routes. So we've learnt about all of the loopbacks, 1112, 1113, 1116, which are all in area 0. And then we have then learnt about the individual point-to-point links in area 0. And we've also learnt about the point-to-point link in area 2, 10, 10, 10, 2. If we have a look at router 6, show IP OSPF, show IP route OSPF, and see the OSPF routes. There we go. We can see that we have now learnt obviously about the two links 10, 10, 10, 1 and 10, 10, 10, 2, which are in area 1 and area 2. We've also learnt about the loopback address, which is also in area 1. So you can see that's labeled as inter-area also. Perfect. So we have area 1 participating and connected to our backbone. And now we're going to configure area 2. But before we move over there, why are we splitting this up like this? Well, if we split this up like this, it allows us to control performance of the OSPF across a larger network. If everything was all in area 0, if there was a change to one router in area 0, that change then needs to propagate to all the other routers within area 0. And you can understand that'll be quite a large number of changes. If we then make a change here in area 0 now, that change is going to be contained to area 0 and not spread into area 1 because there was no change over here. So the area border router keeps those changes within the zone. So that's the key performance. It's just all about performance. You can have networks which happily run and work just fine as having everything as what we call a flat network, everything in area 0, and it will work perfectly fine. But for segregation or for control of summarisation, which we're now going to do in area 2, you may want to break your network up into manageable areas. So if we look at area 3, router 3, sorry, it's connected to the backbone and it's connected to area 2. And within area 2, we've also got two subnets, 2/24 subnets configured on two of the router interfaces, which are going to be advertised out of this allocated /16. So first we're going to set up OSPF and we'll have a look at the other routers and we'll see what shows up in the routing tables. And then again, for performance reasons, we're then going to make some changes and summarize the networks out of area 2 to help reduce the table size. Because like if we look at this /16, if we break that down into multiple /24s, that's going to be a lot of individual /24 networks that need to be advertised into the backbone and into the area 1 routers to reach any of those networks. But we may take some out, we may add some in, but then if we've got a /16, wouldn't it make sense just to advertise this single subnet to let everyone know that, hey, if you want to reach anything out of here, you've got to come via this ABR into area 2, and that's where you can find all the routes for this network. Right, so let's jump on to router 4. And so again, on router 4, we are going to configure our OSPF process, but we've got 3 interfaces again. These 2 are going to be passive. So we're just going to be advertising these networks. We're not going to be expecting any OSPF processes on this side. So we're going to advertise this one. So our only non-passive interface is going to be this one, where we're going to be forming a neighbor relationship. So router OSPF, I'm going to router ID, router process is going to be 2, and the area router OSPF process 2, our router ID is going to be 1.1.1.4. Passive interface again, bring this up, is going to be default, and we're going to do no passive interface on G0/0. Let's just double check G0/0. Perfect. Int L0, IP OSPF 2, area 2. Int G0/0, IP OSPF 2, area is 2, and our IP OSPF network type is point to point because we're going router to router. Let's save that for the time being. Let's have a look at our show IP OSPF neighbors. You can see we have a neighbor relationship with the ABR from router 4 to router 3. Show IP OSPF, show route OSPF. And we can see that we have learnt about the external route to the internet. We've learnt about the other loopbacks in area 1, and we've learnt about the loopbacks in area 0. And we've learnt about the individual paths between the routers within area 0 and area 1. What does it show? IP OSPF border routers. There we go. So we can see 1.1.1.2 and 1.1.1.3. So we can see 1.1.1.2, this one over here, is a ASBR because again, it's advertising the default route. So it has external gateways. So it's an ASBR connected to separate autonomous systems. And then we have our ABR 1.1.3, router 3, which is connected to area 0 and area 2. So now whilst we're on router 4, let's advertise our 2 subnets, 172.21.1.1 and 172.21.2.1/24 into the network. And we'll go and have a look at some of the other gateways and see what routes we're receiving. So int G0/1, IP OSPF 2, area 2. int G0/2, which is the same. And we'll save that. So we'll do a show run. So we're advertising our loopback. We have our point-to-point link back to router 3, which we are running an OSPF process on. So we have a neighbor relationship formed, and then we are then advertising G0/1 and G0/2 into area 2 because we may have other routers here that we may in the future want to receive routing information. So our router OSPF process 2, our router ID, and our non-passive interface. So we've configured this router. Let's go and have a look at 6 again and see what we're seeing now. So we jump over to 6 and we'll do a show IP route OSPF. There we go. We can see that we have learnt about the 2 networks within area 2. We've received 2/24 routes. Now, like I said before, you can imagine if we started advertising every single /24 out of that /16 block, that's a lot of individual /24s that will start to show up in the table, all going towards the same gateway. So the way we're going to tie it up is here on this area border router. What we're going to do is we're going to summarize this address block because we are using this address block within area 2. To reach it, you have to come via router 3. So as we've seen here on router 6, we've currently got 2 routes to that location. If I jump over to router 1 and I do the same, we can see that we're also seeing the 2 routes. So for us to reach 21.1 and 21.2, we're going via our router here. So every single one of these routers has got a full list of those 24s over to here. Now we're going to simplify this and reduce the size. So we're going to go onto our area border router, which is router 3. And we're going to go into our router process. So config T, router, OSPF 1. And we're going to do area 2, range. And the range was 172.21.0.0, 255.255.0.0. So the /16, that range should be summarized to area 2. So we'll hit that. We'll jump over to router 1. Let's take a look at the table. And there we go. We can see that now, instead of those individual /24s, we've now got just a single /16. So router 1 should now be able to ping 1.1 and 2.1. So let's test that. If we ping 172.21, 1.1, there we go. 2.1. What about 3.1? There we go. We can see it can't reach it because we don't have an interface in there. But what if we did? What if we configured another interface on router 4 for, say, 3? So let's jump on to int G0/3, IP address 172.21.3.1. There we go. So we can see it's up. If we try and ping 172.21.3.1 locally, we can see that we can see it. If we jump over to router 1, so have a look at our route. We can still see the 16. Obviously, it's going across via 10, 10, 10, 10, 10, 1, 1, which is this router. So let's jump onto here and see what we're seeing now. That's router 2. So if we do a show IP route on here, and we look, we can see that we're seeing anything for 172.21.00/16, go to 10.10.02. So 10.10.02, it's coming across this way, which is going to router 3. So let's have a look at router 3. Show IP route, OSPF. And we can see that because we're the area border router, we have those routes. But we do not have a route for 172.21.2.3. So just because we're advertising that whole /16 to all of these other routers, we still need a route to these addresses. So we need to jump back onto router 4, and then our int G0/3 interface, we need to advertise that to our border gateway router. So IP OSPF to area 2. So we will advertise that. We'll come back to router 3, which is our ABR. We'll have a look at our routing table once more. And we can see that we are now advertising network 3 to our router 3, our border router. So we can see we've got 3 individual /24s here. And now if we jump back over to router 1 and we take a look at our routing table, again, we only have the /16, but we should now have reachability, because by the time we now follow the path through and we get to our border router knows how to reach 21.3.0/24. So there we go. We've managed to summarize these 3 networks from our border router to everything else across the network to say, hey, you want to receive anything, you want to send anything to this whole subnet, come over here because I have the routes to all of those networks. And then what we've done is only this one router has to have the list for every single one of those networks. All of these other routers are only having a route to this one entry. So it reduces space, and it obviously increases performance and reduces the update size that has to happen between the routers. Also as well, when we make a change in our individual area, we're not affecting any of our other areas by making that change. These other areas are only seeing, this network here only has a route to 172.21.00/16. The more of the /24s that we add, there's no change here. It can always know that anything to go to 172.21.00/16 comes across the network and comes to router 3. So again, you're stopping that requirement for propagation of changes that have to go across the network. Well, and that's it. And due to time constraints this week, sorry, there's no PowerPoint presentation to go along with this. It's just more about showing you why and how we configure multiple areas, how we can summarize from one area into another, how every area must be connected to the backbone area, and how we can advertise and originate defaults into our network. We can obviously also advertise static routes to other gateways rather than just originating default. We can redistribute subnets, static routes that we decide to tag. We can tag those and redistribute them into the OSPF process, and then our other areas will learn about them as an external route. So that's just a brief overview there of multi-areas. If you're not already liked and subscribed, that'd be fantastic if you could. We're climbing. We're nearly at 400 subscribers so far. Be great if we could, like I said, we can reach the 500 mark before the end of the year. And I will see you next week.